Hello everyone. In this video, we will solve a few practice sums based on our introduction to irrational number. Let's do the first one. State whether the following statements are true or false and justify your answers. Every irrational number is a real number. Now we know the real number is made up of irrational number and rational number together. That means irrational numbers are part of real numbers, rational numbers are also part of real numbers. And hence the first statement, every irrational number is a real number, is true. Every point on the number line is of form root m, where m is a natural number. M is a natural number, that means m can be 1, 2, 3, 4 and so on. Now, if I find root of 1 on a number line, this will represent somewhere here. This is root of 1, let's say. And this is going to be the root of 2. But there are so many numbers in between. We know that there are indefinite numbers between any two rational or irrational numbers. And so we cannot say that every point on the number line is in the form of root m, which is where m is a natural number. Because these are definite number of points. And between them there are indefinite number of rational and irrational numbers between them. And hence this is false. Let's do the next one. Every real number is an irrational number. That's not true, because real number also consists of rational number. So every real number cannot be irrational. Real number is made up of irrational as well as rational numbers. Again, this is false. Let's do the next one. Are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is rational number. We know the positive integers. Let's take 1, 2, 3, 4 and so on. Now out of these, we know 4 is a perfect square. It's a perfect square number. So if I find root 1, I'm going to get irrational number. Root 2, irrational number. Root 3, irrational number. Root 4 is equal to 2, because 4 is a perfect square number. So its square root is also a rational number. And hence this statement is not true. Square roots of all perfect squares is also a rational number. Show how root 5 can be represented on a number line. Now to represent root 5, I can see that 5 is equal to 4 plus 1. And 4 is a perfect square. So I can represent 5 as 2 square plus 1 square. And that gives me a Pythagoras. So 5 I can represent as root 5 square is equal to 2 square plus 1 square. So if these are two legs of a Pythagoras, this is going to be the hypotenuse. And using this knowledge, I will be able to represent root 5 on a number line. Let's do that. Let's first draw a number line. So here is 0, 1, 2, 3 and so on. Now I get one leg from 0 to 2. The length of this leg is going to be 2. So this is my one leg of my right angle triangle. So let's draw this line from 0 to 2, which is 2 units line. And at 2, I'm going to draw a perpendicular here, which is equal to 1 unit length. So let me draw that. So we have drawn a perpendicular from 2, which is 1 unit length. So we have drawn this line which is 1 unit length. Let me write it here. This is 1 unit length, and this one was 2 units length. Now if I draw this hypotenuse, what would be the length of hypotenuse? We know length of hypotenuse is hypotenuse square is going to be sum of squares of legs. So that is 2 square plus 1 square, which would be 4 plus 1, and it is 5, which is hypotenuse square, and hence hypotenuse is going to be root 5. So let me draw this hypotenuse. And now if I draw an arc of the length equal to this hypotenuse, this arc is going to cut this line here, and that is going to be our root 5. This point is going to be our root 5 on number line.
I am sure you have liked the video. Hit the like button and leave your views in the comments section below. Do watch our other videos on this topic. Subscribe our channel and click the bell icon to get notifications whenever we upload new videos. You may also download the YouTube app at the link provided in the video description. Till we meet again, goodbye.